Hello and welcome back to our video lecture series. In this video we're going to talk about the null and alternative hypothesis. But before we get into the difference between the null and alternative hypothesis, let's briefly review the three elements that are necessary to specify any hypothesis. The first element we need to specify a hypothesis is the unit of analysis. The unit of analysis refers to the range of cases that we're going to be comparing in our study. So some of the examples we saw with the homework and some of the other examples that we use in the class are, let's say, cities. We used a data set that had about 200 cities. Those 200 cities form the unit of analysis in that data set. If I were looking at students in grades, let's say, students would be the unit of analysis. I'll use an example earlier in the video lecture series that looked at school districts when we were looking at SAT scores. So the unit of analysis, once again, refers to whatever cases we're going to be comparing or analyzing in our study. They are the basic element that we're going to be collecting data about or collecting data on. Now, once again, to do a statistical analysis, you need a sufficient number of units in order to conduct a viable statistical study. That's actually what separates case study research from statistical research. Case study research, by definition, only examines one unit of analysis. You have a single case. Whereas for statistical analyses, you need a whole broad range of cases to draw statistical inferences from. The second element you need to specify hypothesis is a dependent variable. And as the name implies, a dependent variable must vary or have variance. That is, the values of the dependent variable must change over the units of analysis. If you collect, let's say, data for a series of students and that variable doesn't change, it's the same value for all the students, or it's very close to being the same value for all those students, you basically don't have a variable. You have what is called a constant, and you can't really explain in a statistical study the presence of that constant. So you do need a dependent variable to actually have variance or to vary across units of analysis to make an analysis work. And then finally, the third element is an independent variable. And this is your cause. So if you think about your dependent variable as the effect, what is causing the variance in that dependent variable? What independent explanation or independent variable's variance explains the variation in the outcome? So once again, using our city example, let's say we're going to look at 200 cities that have very different crime rates. Well, what variable could explain why some cities have much higher crime rates than others? Well, it might come down to, let's say, education. So we might hypothesize that cities with different education levels are going to have different crime rates. And then, of course, we can think about the direction that relationship might flow in. The two most common specifications for relationships would be positive and negative. So one way we might say it is that as the values of x increase, we would expect the values of y to also increase for our units of analysis. An intuitive example might be something like, as the number of study hours increase, grades in a class should also increase for students in the class. Conversely, we might specify a negative relationship where we would say that as x increases, we would expect y to decrease for our unit of analysis. So going back to our city example, we might say that as education levels increase, we would expect crime rates to decrease for cities in the United States. Now, the hypotheses that we're talking about are actually alternative hypotheses. We are positing a relationship between x and y, which forms an alternative to what we call the null hypothesis, or the empty hypothesis. The null hypothesis is the hypothesis that we are trying to denounce, or trying to reject. So we're trying to say that if a relationship exists, we are rejecting a hypothesis that says no relationship exists. So the null hypothesis simply states that for a unit of analysis, there is no relationship between x and y. Our alternative hypothesis is our expectation that there is a relationship between x and y. We often think of that relationship as being positive as x increases, y also increases, or negative as x increases, y decreases. So let's just basically take a look with some notation here on how we go about specifying the null and alternative hypotheses for a research project or research paper. Once again, keeping in mind that this framework of a null hypothesis and an alternative hypothesis are really utilized or used to characterize how we think about testing statistical relationships in data. Alright, so let's take a look at how we specify the null hypothesis. Here you can see that we begin our null hypothesis specification with a capital H and a subscript 0. This stands for the null hypothesis, or the naught, N-A-U-G-H-T, hypothesis, the nothing hypothesis. The nothing hypothesis can be stated simply as, for a given unit of analysis, there is no relationship between the independent variable and the dependent variable. To use an example, we might say, for cities, where cities is our unit of analysis, there is no relationship between education levels and crime rates. You can, of course, include any variables that you want. You could say, for survey respondents, there is no relationship between number of hours studied and the grade the student receives in the class. You could also say, for school districts, there is no relationship between income levels and SAT scores. Next up, we have the alternative hypothesis. The alternative hypothesis contrasts the null hypothesis by positing that there is a relationship between the two variables. If you have a directional hypothesis, you may state H subscript A, for the unit of analysis, an increase in the independent variable leads to a or an increase or decrease in the dependent variable. Once again, what you select depends on what your specific hypothesis is. So in our example, we might say, for cities, an increase in education levels leads to a decrease in crime rates. For students starting their statistical analyses, you'll want to specify both your null and alternative hypothesis. It'll really help make some of the concepts about probability and how we use that probability to assess whether or not to reject or fail to reject the null hypothesis a little clearer.